So first things first, we're gonna do questions on the homework.
Okay, I have a question on number 5 because
I got it, I'm ready.
the way the book wrote it, like there was a comma in my book, and like I didn't know what that meant, so I think, but there that was an accident. But can you still do it anyways, please?
Clearly, a comma there is a misprint.
Yeah, that's what I was thinking, but I was like, what if it's not?
Okay, so they're telling us we have a sequence of numbers here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, sequence of numbers. And we're starting with 8. And they're giving me a recursive rule. Now recursive means can I spell recursive? That has to have an S in it. Recursive definition, and they're saying a sub n equals a sub n minus 1 minus 4. This means that the term before it, I have to do what to get the next term? Subtract 4. So if I start with 8, to get to the next term, I have to subtract 4 every time. So this is going to be 4, 0, negative 4, and then they want the 8th term. Well, the only way to get to the 8th term is to continue subtracting 4. Because it's recursively defined. And that's what makes recursive definition sometimes difficult. But there are some sequences in the universe that can only be defined recursively, and one of them is the Fibonacci sequence, which if I have some time, I will go over with you, but not today, it's a Wednesday. All right, so subtracting, negative 8, negative 12, negative 16, negative 20. So our answers are, this is a sub 8. That's the number in the 8th spot. And these are the first 4 terms. Okay, sorry, book has a typo there. Moving right along. Patio deck. I'm going to hold off on this one until we talk about how to sum sequences. All right? When I say hold off, I mean in less than a half hour. And then I'll come back to this one. Fair enough? All right, so you've got some guided notes in your hands that we're going to talk about, so that's good news. You don't have to write them all down. I apologize as the guided notes go on further, it gets smaller and smaller, but you know. Hopefully. I conserved paper. Okay, yes.
In the book, they were saying on all the recursive definitions as greater than or equal to 2. I don't remember that. Is that just something you write for all of them?
No, not necessarily. They're just saying that you have to start off with the second term because you have the first term.
Okay, so we don't need to write that.
So we're starting with a sub 2.
Right.
Right? Yeah.
Write that.
No.
Okay.
All right. So we recall this one, right? The one that we started with, which was 3, 5, 7, 9. We call that one arithmetic because it has a common difference, right? Which is 2. This is arithmetic. How is this one different?
It's multiplication.
Instead of a common difference, it has a common
Ratio.
would you say common, most people would say common multiple, right? But it's a common ratio. And we're going to call that common ratio R, the ratio. And this one is geometric. Now, common ratio, R. How do we figure out what R is? What we're going to do is we're going to take the second term, which is 6, and divide it by 3. And what do we get? 2. And then for it to be a common ratio, that has to equal the third term, which is 12, over the second term, does that equal 2?
Yep.
Has to equal the fourth term divided by the third term. So it's like you're dividing the term by the term in front of it, and you better get the same ratio. That's why they call it a common ratio. All right, so let's recall the formula for the nth term of the arithmetic sequence. Remember how we got it?
Is A1 plus
A sub 1 plus
N minus 1 times D.
n minus 1 times d. Good. What if I wanted to find the general formula for a geometric sequence? I'm trying to not be so loud with the writing. So my handwriting might need to adjust here, sorry. No, I think it doesn't sound so quack, 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 right? Cool, so we're gonna start with the first term. And then what do we do to the first term to get to the second one? We multiply it by r. And then the third term, what do? We take the second term and multiply it by r. So this would be a sub 1 times r, which is the second term, times 1 more r. And then a sub 4, similarly, would be a sub 1 times r times r times r. And then we make that big leap to the nth term. Yep,
A sub 1 times r to the n.
a sub 1 times r to the
N minus 1.
n minus 1, yes. This right here is the formula, general formula. Of a geometric sequence. Now, why are we, let's refresh our memory, why are we trying to find an nth term?
So we don't need to write that.
So we don't have to, if I wanted a sub 20, I wouldn't have to write out 20 terms to get a sub 20, right? All right, similarly to the general formula for the nth term on an arithmetic, I had to have a sub 1 filled out and d. That makes a sequence unique. So those two have to be filled out in my nth term to define a sequence. What about in a geometric? What are you supposed to have filled out? A sub 1 and r. So those two things have to be filled out. Now, this is the explicit formula. Now, what do I mean by explicit? That means if I tell you n, you know what the term is. Yep, so if I said n was 5, you would say, well, that's a sub 1 r to the 4th. And you know exactly what number was in the sequence. What about the recursive definition? Now, recursive means you're taking the term before it and doing something. So if I want the term, I'm going to take the term before it, which is a sub n minus 1, and do what to it? Multiply by r. Again, the drawback being, you have to know the term in front of it in order to use it. Okay? So let's find the general formula for our sequence that we had above. What did we start with?
3.
Yeah. Our sequence above was 3, 6, 12, 24, dot, dot, dot. And we want to find the nth term for this one. Well, it's gonna be a sub n equals, what's a sub 1? 3. And we already figured out what r was. 2 to the n minus 1. There's the nth term for our sequence. So let's see if it works. Let's say n is 4, so a sub 4, that means the number in the fourth spot. Now we already know, right, that the number is 24. If I let a sub 4, n equal 4, I can say this is 3 times 2 to the third, and 2 to the third is 8, 8 times 3 is 24, so it works, right? Now, I have to caution you here. Maybe not so much because you're honest folks, but Taylor Swift used to say, never ever get back together. Never ever multiply these together. Unless they have the same base, and then we can talk about multiplying them together. But these clearly do not have the same base, do they? 3 and 2. So they need to remain separate. This is not 6 to the n minus 1. No, because PEMDAS says, what do we have to do first? PEM, E, exponents has to be before M. And since we don't know what the exponent is, we're stuck. Got it? All right. You think I'm making a big deal of it. I am, because I don't want us to miss any points later. Okay, move right along. We're going to decide whether this sequence is geometric or not geometric. Not geometric. Why?
Because 1/3
Negative 1/3?
is not the same.
So it's not equal? Negative 4/-1, right?
Yeah.
There is no common ratio, so this is not geometric. Good. What about this next one?
Yes. Yes.
Geometric? And r is equal to 2. So if we were going to write the nth term for this one, we would say a sub n equals negative 2 times 2 to the n minus 1. Very nice. Now clearly these have the same base. I mean, the negative we can leave on the outside, but I would leave this. Because can you see a sub 1 when you look at this formula? Can you see r? If you combine them, even though they have the same base, you lose what a sub 1 is. Okay, so, all right, what about this next one? Is 1/3 over 1/2 equal to 1/4 over 1/3? Guess what? The answer is no. So this one is not geometric. Even though it still has a pattern, doesn't it? I mean, you can tell me what the next one would be. 1/5, right? Even though, so that's not geometric. Okay, what about this next one?
That one is geometric.
Okay, it is geometric. Now, how do we figure that out? I'm going to go to a little, we would say negative 2/3 over 4/9. So let's figure out what that is. Negative 2/3 times 9/4 equals
Negative 3 over 2.
negative 3/2. And so what do I have to do? I have to test the, this is 1 over
Negative 2/3.
negative 2/3, which if you keep change flip, you get negative 3/2. So this is geometric with r equal to negative 3/2. So if I wanted to come up with the nth term, it would be a sub n equals the first term, right, which is 4/9 times r, which we figured out was negative 3/2 to the n minus 1. We'll just leave it like that. Now, could you, knowing what r is, come up with the next 4 terms?
Yes.
Sure. What's happening?
And then you square. They're like, it's 150 square.
Right, so this is not even a common difference, is it? I mean, this is 3 and then this is 5.
It's like, so next one is 16.
Yes, that's right. So she already came with up with a sub n here. What is it?
Well, yeah, square. Yeah,
You
square.
agree with that?
Yes.
Now that we just came up with, that's not arithmetic or geometric, but it does have an nth term. And you can predict what all the other ones are, but this one is not geometric. Because it doesn't have a common ratio. Got it?
Can you scroll up to just the line above that?
I'm sorry?
Can you scroll up just one line?
Yes, ma'am.
Okay, thank you.
Questions so far? Write a formula for the nth term of this geometric sequence. So I'm already telling you it's geometric, so it's got a common ratio. Recalling the formula is a sub n equals a sub 1 r to the n minus 1. I have to figure out what r is and a sub 1. So a sub n here is 2, which is, this is the first term, this is a sub 1. And then r is negative 4 to the n minus 1. And you're done. That's all there is to it. And then if I asked you for a sub 8, what would you do? The term that's sitting in the 8 spot, you would just plug in 8 for n, and you'd have a very large number. Because it would be 4 to the 7th. Very large negative number. And this sequence is an alternating sequence, isn't it? Interesting. All right, moving right along. Write a formula for the nth term of the geometric sequence given the first term and the common ratio. Wow, this is a piece of cake. A sub n equals a sub 1 r to the n minus 1. Well, Mrs. Muller, there's no trick here. Is there? You're giving me what I need.
Oh. Yeah, I do.
Should be negative 1.
So a sub 1 and equals negative, and put that on the outside, 6 to the n minus 1. Yes, there's no trick there. If you know a sub 1 and r, you're done. This one here is going to be a sub n equals 3 times negative 2 to the n minus 1. Good luck with that being all your problems, right?
That's efficient.
Yeah, lots of those in the You just make the whole test like just this.
I know, more people like this stuff. All right, here, move right along. Write a formula for the nth term. The geometric sequence given a term that's not the first one and a common ratio.
You can solve for it.
Okay, yes, you can solve for it, but
5 equals 2.
this is kind of what I like to do sometimes. Since I have the second one, I'll put 18 here. Right, and just, you know, just for kicks. This is a sub 1, and this is a sub 2. How do I get backwards? Okay, multiply by negative 9. That's right. So that's going to be negative, what?
162. Maybe 162.
Negative 162 goes here. So everybody follow what we did? You just divide by the ratio. Okay, so now we know a sub 1. And if you want it, this one would be negative 2, right? So this is an alternating sequence. And so a sub n, the general formula is going to be negative 162 times negative 1/9 to the n minus 1. Now I caution you, boy, is it tempting? Get rid of those negatives? You're saying cancel me out. But are we? No. Because PEMDAS says, all those little things that are trying to say, cancel me out, you're not going to do it. What? Where I'm not giving you any of them? Okay, so I'm going to show you a technique. Now, R is not ever going to be 0, or we have a boring sequence, right? It would just be 0 all the way across, right? So R won't be 0. So I'm going to say we have an n here that's 4. So then I know A sub 4 is equal to A sub 1, which I don't know. I don't know R, but do I know N?
Yes.
So this is gonna be 4 minus 1, which is 3. And that means I know negative 64 equals A sub 1 R to the third. Okay? And then they're also telling us that N equals 6. So I know A sub 6 is gonna equal A sub 1, which I don't know, R to the fifth. But A sub 6 is negative 1024 equals A sub 1 R to the fifth. Now this is an equation, a system of equations. It's not a system of linear equations, so we cannot use combination. This is a system of exponential equations. So we can either use substitution, which I think is okay, but I like to divide these two equations, because what happens if I divide every time?
A sub 1.
A sub 1s are going to cancel out, aren't they? So I like to solve these systems by dividing. And there's an easy way to divide and a hard way, or a more difficult way. I think that you should always put the R that has the highest exponent on top. Okay, so I'm going to say negative 1024 over negative 64 has to equal A sub 1 R to the fifth over A sub 1 R to the third. So what happens so nicely when you divide them? The A sub 1's cancel on the right side, and that turns out to be 16 equals R squared. God bless you. So R could be plus or minus 4. So I have two possible sequences. So let's see what they are.
So is my trains.
No,
Those go up.
they go to our watch. Then we're going to say R equals 4. We're going to do the positive 1 4 first. All right, so they said our first, when they gave us the 4th and the 6th, right? So 1, 2, 3, 4, 5, 6. So they told us that the 4th one was negative 64. 1, 2, 3, 4. They told us this was negative 64. And the 6th one was now how do I figure out what A sub 1 is? Should we use this equation and use the easier equation? Which one's the easier one? I think this one's the easier one. We can say negative 64 equals A sub 1. We're going to use the R equals 4 one first. That's an R, not an N. So that's 4 to the third. So what happens? We have negative 64 equals, that's 64, A sub 1. So A sub 1 is negative 1. So let's plug that in. So this is negative 1. We're multiplying it by 4. Negative 4. We're multiplying it by 4. Multiplying by 4, does that work? And then negative 256? It works, right? So this one is not alternating. It's all negative. So then we can let R equal negative 4. And we can say negative 1,000, we'll use the same formula. Negative 64 equals A sub 1 now, negative 4 to the third. What happens now with the negative when you cube it? But it will eventually cancel, you're right. So this is negative 64 though, A sub 1, and A sub 1 now is positive 1. So the second possible is when R is -4. 1, 2, 3, 4, 5, 6. And we know that, we know that the fourth term again was -64, and then -1024. And now I'm saying that the A sub 1 is 1 multiplied by -4, -4 times -4, positive 16, -4. Then we get positive 256. So it works, doesn't it? But we have two separate A sub n's, don't we? A sub n here equals A sub 1, which is -1 times 4 to the n minus 1. And this one's going to be A sub n equals 1, which you don't really have to show, but I'll show it for demonstration purposes. And then use the R of -4. So there are two possibilities. So you're going to have two possible series when you have an R to an even power here when you're solving. Okay? Because to an odd power you won't. Okay? Because of time, I'm going to keep going. I have a section here in your notes on how to do this with your calculator. Okay? And I'm talking step by step. What is a sequence? A sequence is a list of numbers, isn't it? So we're going to go second list. See how creative I was in getting the little keys in here? I'm sorry, I'm having something back there. And then you press to number 5, sequence, and this should pop up if your software is up to date. Now, I have my calculator in sequence mode. All right, just play around with this, and I'll do more with this. And then I've got, an example where I actually do it, and you see what the result is. So you can just practice with that. All right. Summation notation. Now I'm sorry that this is blanked out here, and this is a K. This is the Greek letter S for sum. It's a sigma, but it's for sum. All this is a shorthand mechanism for adding a list of numbers. Okay? This K is called the index of summation. I'm never going to ask you that, but that's the index of summation. 1 is where we're starting, and 6 is where we're ending. Okay? So what's going to happen is, and these go in increments of 1. I'm going to let K equal 1, and I'm going to substitute in my expression when we get 1. And since this is a sigma, it means we're adding. And then I'm going to bump the counter up to 2, and then I'm going to plug a 2 in here. We get 6 minus 4, which is 4. Plus, bump the counter up to, now where am I? 3, so this is 9 minus 2, which is 7. Plus, now I'm going to bump the counter up to 4, and that's 10. Plus, bump the counter up to 5, and that's 13. And you see the pattern, right? The last one is 16. And somebody with their fast fingers is going to tell me what that equals. What? 51. 51?
Sigma implies summation of the whole
Sigma, yes, Roman S.
Are we gonna get a negative one?
You could.
Okay. But what would that notate? Like what would
No,
that
this would be plus a negative number. That's all.
Oh, okay.
All right. You got it? Now, not all summation notation has K's. You can have an I. Okay, so this says start with I equals 2. So what happens when we do that? We get square root of 4, which is 2, plus, bump the counter up to 3, square root of 6. And how do we do that? Plus, which is 2 root 2 plus square root of 10. All the way up till we put in 9. Do you see what we're doing?
So
what it gives me on the bottom is where it's starting.
Yes, and this is the start, the 2 is the starting spot and 9 is the stopping spot.
And you're always going up by 1.
Yes.
Okay.
You can do this on your calculator. If you hit the math button, Math. and then you scroll down, you should see the summation. You see the summation symbol. And then you can just type it in, just like you see it. Math, I think is it 0? Huh?
We can just put any letter for.
Yes, you can put, you can put X if you like, so that works. That's where you stop, that's where you stop at equals 9, okay? Do you get the answer? Do we get it?
Okay, what would you type?
I have 1
Okay,
minute. What?
Teach. Oh, that's good. Alright. It's probably, so.
And then you can do the same thing with your geometric, which is the next part. Anyway, all right, and so that's all I can do in this time allotted today, so. So I will have to look at the homework.